Hello, my name is Abdullah and today I'm going to be talking about my math investigation. For this investigation, we are trying to find out and calculate how long it will take to fill out the site of the Al 2 landfill. After that, we are supposed to find out if GPS is creating too much waste and is there a solution to this problem. We have been given the length, width, height of the Al 2 landfill. Therefore, we can calculate the volume. But first, you must find out the upper and lower bounds. The height of the landfill is 100 meters and doesn't tell us that it is rounded. The width, although is 1.25 kilometers, rounded to 2 decimal places. The lower bound would be 1.245 kilometers and the upper bound would be 1.255 kilometers. The length is 1.5 kilometers, rounded to 2 decimal places. The lower bound would be 1.45 kilometers and the upper bound would be 1.55 kilometers. The equation of finding out the volume is length times width times height. This means that the calculation of the volume would be 1.25 kilometers times 1.5 kilometers times 100 meters, which would give us 175,500,000 meters cubed. The lower bound calculation would be 1.245 kilometers times 1.45 kilometers times 100 meters, which would give us 180 kilometers and 525,000. The upper bound calculation would be 1.255 kilometers times 1.55 kilometers times 100 meters, which would give us 194,525,000 meters cubed. Then this is how we'd present the data. To calculate the volume of the water bottle, we have to do pi times the radius squared times height. After measuring my own 500 milliliter bottle, we found out that the radius is 3.5 centimeters and the height is 20 centimeters. Therefore, the formula would be pi times 3.5 squared times 20, which also means that it's pi times 12.25 times 20, which would give us 769.690200 and so on. After that, I rounded my answer to 1 decimal place, which would give us 769.7. This will give us the volume of the water bottle and is in centimeters cubed. To find out how many bottles you need to fill up the landfill, you must take the volume of the landfill, convert it into centimeters squared, and divide it by the volume of one 500 milliliter bottle. To convert the volume of the landfill into centimeters cubed, we'd have to times it by 100, which would give us 18,750,000,000. Then we take that number and divide it by 769.7. This will give us 24,360,140.3144. Then we round it to six significant figures, which is 24,360,140. This number gives us how many bottles we need to fill up the landfill. Now we have to do the upper and lower bounds. For the lower bounds, we take 180,525,000 and multiply it by 100. We then get 18,052,500,000 centimeters cubed. We divide that by 769.7, which would give us 23,453,943.0947. We then convert that into 8 significant figures, which would give us 23,453,943. For the upper bounds, we'd have to take 194,525,000 meters cubed and multiply it by 100. This would then give us 19,452,500,000 centimeters cubed. We have to take that number and divide it by 769.7. This would then give us 25,272,833.5715. We then have to round that to 8 significant figures and 0 decimal places, which would give us 25,272,833. We then present the upper and lower bounds data in this particular way. Now the limitations and assumptions. Firstly, I assume that all the water bottles are 500 milliliters. I assume that the teachers don't bring their own plastic water bottles. I also assume that the plastic bottles were not squeezed in any way, shape or form. I assume that I must do everything the same for the upper and lower bounds. A limitation is that there can be holidays, long weekends, and even field trips. Another limitation is that my calculations aren't exact or accurate due to my degree of accuracy. After putting out my survey, I now have my results. 37 people said they throw away one water bottle, 9 people throw away 2 water bottles, 2 people throw away 3, and 1 person throws away 4 water bottles, and 21 people don't throw any. In total, this would mean we'd have to add 37 and 18 and 6 and 4, which would give us 65. In total, I got 70 responses, which means to find the average, I must divide 65 by 70. So when I do 65 divided by 70, I would get 0.92857 and so on. We'd then round it to one decimal place, which is 0.9. To find out how many water bottles are wasted in the whole school per day, I must multiply 0.9 by 806, which is how many students we have in the school. After doing that, I'd get the answer 725.4. This is how many water bottles are assumingly wasted per day. After using a UAE-based website, it tells us that there are 182 school days a year. To find out how long it will take to fill up the landfill, we would have to take the amount of bottles needed and divide it by the amount of bottles wasted in the whole school per day. So therefore, the calculation would be 24,360,140 divided by 725.4. It would give us 33,581 and a lot of decimals. We'd round that to 5 significant figures, which is 33,582. We then divide that by 182. We'd get 184.5 and a lot of decimals. We then round it to 3 significant figures, which is 185. This means that it would take 185 school years to fill up the landfill. We now have to do the same for the upper and lower bounds. So for the lower bounds, we got 23,453,943, and we divide it by again 725.4. This would give us 32,332.4276 and so on. We then round that to 5 significant figures, which is 32,332. We divide that number by 182, which is how many school days you have a year, as said. We then get 177.6 and so on. We have to round that to 3 significant figures, which is 178. So this means that the lower bound calculation would equal to 178 school years. We now do the same for the upper bounds. We have 25,272,833 and we divide it by 725.4. We'd get 34,839 and a lot of decimals. We then have to round that to a whole number, which would give us 4 significant figures, 34,840. We take that number and we divide it by 182, which equals 191.42857 and so on. We then round that to a whole number or 3 significant figures, which is 191. Now for my final answer and conclusion. So first I represented the data for the upper and lower bounds. We got 178 school years to 185 school years to 191 school years. In conclusion, I think JBS are producing too much plastic waste. Even though it would take around 185 school years to fill up the landfill, I think producing more than 700 plastic waste a day is too much. A solution to this problem is that we can sell non-plastic water bottles and slices, because that is where everyone has access to. We could also publicize the fact that there is too much waste being produced, so that we can convince the people. We could also bring our own non-plastic water bottles that we fill up every time it's empty instead of just throwing away a plastic one.